Though the global climate might seem infinitely complex and chaotic, it actually works like a simple, predictable machine. Many people don't understand it, or they confuse it with everyday weather, and this has led to a lot of needless anxiety, debate, and economic suffering. I feel a deep sense of responsibility to share a simple first principles template of how the global climate machine actually works. It is built entirely on basic physics, rules like the conservation of energy and thermodynamics. Once you understand the mechanics of this machine, you will understand exactly why our planet is changing today and where it is heading tomorrow. Let's begin. The climate machine is made up of a few simple parts and a series of simple physical reactions repeated a zillion times. These reactions create three main forces that drive the entire system: the energy imbalance, the transport conveyors, and the feedback loops. If you can track these three forces, you can track Earth's climate. See how this works. We have to start with the simplest part of the machine: energy absorption. The only meaningful source of fuel for this entire machine is the sun. When a beam of solar radiation crosses the vacuum of space and reaches Earth, only one of two things can happen. First, it can be reflected. If sunlight hits a light-colored, smooth surface like fresh snow, ice, or thick clouds, up to 90% of it bounces straight back into space. It does absolutely nothing to the climate. We call this reflectivity albedo. Second, it can be absorbed. If sunlight hits a dark surface like the ocean, a forest, or bare soil, the light is absorbed and converted into molecular motion. That motion is heat. That absorption is the fundamental building block of the climate machine. Every storm, every ocean current, every drought, and every climate zone on Earth is just the system reacting to where that heat was absorbed. Because the Earth is a sphere, the sun's rays hit the equator directly, but strike the poles at a sharp, glancing angle. This means the equator absorbs vastly more heat per square meter than the north and south poles. This creates a massive, permanent energy imbalance. And this brings us to the single most important rule of the climate machine. Heat must flow from surplus to deficit. Physics simply does not allow energy to just sit in one place. The second law of thermodynamics demands that heat flow outward until temperatures equalize. Because heat must flow from surplus to deficit, the Earth is forced to move it. This relentless, never-ending transport of heat from the equator to the poles is the climate system. It works in a chain reaction. When you heat the air at the equator, it expands and rises. Because the air rises, it must travel poleward to cool down. As the Earth rotates beneath this moving air, it spins that air into massive, predictable wind belts. When those wind belts drag across the surface of the ocean, they pull the water with them, creating surface currents. What we call weather is just the chaotic, day-to-day work of these fluids moving heat. Weather is your mood today. Climate is what happens when you average 30 years of that exact same work. Climate is your personality. To move all this heat, the climate machine relies on two massive conveyor belts, the atmosphere and the ocean. The atmosphere acts as both a blanket and an HVAC system. It is incredibly fast. When warm air rises at the equator, it travels north and south, eventually cooling and sinking back to the surface at roughly 30 degrees latitude. Because this sinking air is incredibly dry, it creates a predictable band of descending air around the world. This is exactly why the Sahara and the Australian outback exist where they do. But the atmosphere doesn't just move hot air, it moves water. Think of the water cycle as the Earth's natural air conditioning unit. Evaporation requires energy. When water evaporates from the tropical ocean, it physically absorbs latent heat from the surface. It then travels thousands of miles as invisible vapor. When that vapor eventually condenses into a cloud and falls as rain, it releases that exact same heat back into the atmosphere much higher up, where it can easily radiate out into space. But as fast as the atmosphere is, the ocean is the true heavyweight of the climate machine. Water is incredibly dense. It has a much higher heat capacity than air, meaning it takes far more energy to change its temperature. Because of this, the ocean acts as a giant thermal battery. It absorbs and stores over 90% of the system's excess heat. Because the ocean is dense and heavy, it is slow to charge and slow to discharge. Deep ocean currents are driven by differences in water density. Cold, salty water sinks at the poles, while warm water flows up from the equator to replace it. This global conveyor belt takes centuries to complete a single loop. This is why the climate machine has so much inertia